Hello everyone. Today is day 7 of our 30 days 30 deep learning projects challenge. So let's start. It says that today we have to fine tune hyper parameters with Keras Tuner on a small neural network. For that we will be using what it says we can use telco customer churn dataset. But yeah, let's see. So as to what go to the chat gpt, follow the same steps as we do for all our other problems. So I'll go to the chat gpt and use the same window, context window, as I've been using for our previous problems, so that it helps the chat gpt to generate the response that we have understood previously. So let's start. I'll say, hey, it is day 7 of the challenge, and here is the problem statement. Okay, so we have to do hyper tuning today, hyperparameter tuning. So let it generate first everything, and then we will start with, yeah, start with the process. So it says today we will explore hyperparameter tuning using the Keras tuner, which is a powerful tool for optimizing the hyperparameters of a model to achieve the best possible performance. This will involve tuning different aspects of a neural network, like the number of neurons, learning rate, batch size, etc., to see how they impact performance. Okay, so we will do hyperparameter tuning today, and it involves what it involves the adjusting the number of neurons, playing with the learning rate, we did that, playing with the batch size, and etc., to see how they impact the performance. Now, what is hyperparameter tuning? Hyperparameters are settings that you need to define before training your model, such as the number of neurons in a layer, yes, the learning rate of the optimizer, okay, the batch size, and the number of layers. So we have, if you remember, we have experimented with defining different learning rates and observed the performance of the neural network model. We have added a different number of neurons in the layers. We have been adding, going ahead with 32 as the base size for now, but we today we will explore that with different base sizes and the number of layers. So yes, it says that hyperparameters are these parameters. We adjust these parameters so that we see the impact on the performance of the model. Now, hyperparameter tuning is the process of finding the best combination of these settings to maximize the model performance. Yes, hyperparameter tuning is, we have done this actually. If you remember, when we were solving the our previous challenge of doing 30 machine learning problems in 30 days, we have explored and implemented hyperparameter tuning in couple of problems. So it is a process of finding the best possible combination of the parameters, so that they yield the model's best performance. Now, Keras Tuner is a library that helps automate the process of trying different combinations of hyper. So, which library are we using for this? For figuring out that combination of the settings, we will use Keras Tuner. Okay, so let's start. I don't think we need to, I need to, I do understand what they all mean. It is pretty much clear. I do not find the need of asking again. So I'll go and start with the plan for today. So we will import and install this Keras tuner. We don't have it. Then we will define a simple neural network for tuning. We will use this Keras tuner to find the optimal hyperparameters, and then at last we will train and evaluate the model, best model. So let's create a simple neural network and use Keras tuner to fine tune the hyperparameters. So for step by steps, first step is to install this Keras tuner. So I'll go to my PyCharm. Here I will say pip I'm increasing the font. Last yesterday I saw that the font was not that increasing. I mean that clear. So I say pip install Keras Tuner, and it has installed it. Now I'm going to go and create a new file for today's problem, day7.py, and let's add it to our Git repository. And let's import the libraries. Before that, let's increase the font size here as well. And here's the let's decrease the I mean lower down the terminal window and increase the font size to 15. Now let's mention the problem for today is this: fine tune hyperparameters with Keras Tuner on a small neural network. For building that, let's import the libraries. So we will import TensorFlow as TF from TensorFlow.keras dot datasets. Import which dataset ChatGPT recommends. Okay, so we are using load breast cancer. Hmm. It's a small network, bro. What network? What it is? It is. So let's go ahead and use the dataset from the sklearn itself. The load breast cancer, we will it is a relatively small and great for this task because we want to experiment with the model. So let's keep the dataset small and not put so much time into training a model with large dataset. So let's import the dataset first. So from sklearn, not model selection, data sets, import uh, load breast cancer from sklearn, model selection, import train test split to split the data set into training and validation data sets. From TensorFlow, Keras models, import sequential model, our neural network model. From TensorFlow, Keras dot layers, import dense layer. Yes. Now we want to import what? Last, which is the important thing for today's problem. Keras tuner as KS. KT. It says that it is deprecated. We need to do this. You see, even the ChatGPT code, suggested code is also deprecated. So yeah, let's do what? Let's load the data. Load the data set. So we'll do what? We will load the data set. The data is loaded from which? Load breast cancer. And let's print data and see what it looks like. Let's run this file, day 7. We have a lot of data. Let's see what it returns. So it has dot target names. It returns data, and if we pass this as frames, the data is a pandas data frame. So let's as frame true. Let's pass this as frame. We want it as pandas data frame. Now let's print this, run this. Now do this. Let's use this. Let's again go back to this. Data is true. If true, this data is a panda data frame including the columns and the appropriate data types. The target is the panda data frame or series depending on the number of data. Then will be okay. So dot data and target columns inside this will be what? Will be the pandas data frame. So you see here it says that as frame is true, that this will be the pandas data frame. If target is true, this will be the panda data frame. So we will do what? Data dot data, not data. And here you should see, we'll run this file. See, now this is a pandas data frame. So here we can see the data better. It has many columns. It has mean radius, mean texture, mean parameter, mean area, concavity, worst concave points, worst symmetry, worst fractal dimension. So it has many. It has like how many? It has almost. It has 30 columns and it has 569 rows. Now we'll do what? We'll create the features. Pre-process the data. So we will do process. We are pre-processing the data. Pre-process the data. So we will do create the feature list. Feature list is going to be data at pandas data frame, and here it is going to be data dot target. And we will do what? Let's print this thing. How did I get to know this? Because I was reading the documentation. It was clearly mentioned there. Let's wait. And this is the target. Okay, now target is like this. It talks about whether the customer has breast cancer or not. Yeah, patient has breast cancer or not. So we have them as panda data frame. Now we will do what? We will split the data set into training and validation data set. We will go ahead with 80-20 ratio, where the training will have 80% of the data and we will keep 20% of the data for validation, which is as unseen data to. Yeah, so let's do what? Define and store them in their respective variables, and it is going to be x train, x validation, y, not y train, y validation. And we will use which function? Train test split. Mention here the feature list, the target. This test size is going to be 0.2, which is 20%, and the randomness state is going to be 42 to strictly tell that whenever we are going to run this script, it should generate the same output. So done. Let's do what? uh, and if you want to know more about this, to have explained it very clearly, but in depth, we have done this like more than 30 times when we were doing that our 30 days 30 machine learning projects challenge. So I would recommend you guys to go and do that challenge first, because it will set up the base and then we come back to this challenge. So now we will do what? Define the define hyperparameter functions for building the model. So we'll do what? Define build model. Here we are taking the hyperparameter functions. Here we say what model is going to be sequential model. Okay. Now how do we find it? Let's go and read the what this function says. Yes. So it says that we are doing, here's the explanation. So it has this hyperparameter dot int units, minimum value, maximum value, steps. So it takes the hyper, tune the number of units in the first tens layer, which is from the hyper units, then add that into the unit section, and then the shape is going to be the shape of the in our training data. Then we need to tune the learning rate. For that we are defining the learning rate from this hp hyperparameter choice learning rate. The value will be this 0.001, 0.00001, 0.00001, and then this is going to be the output layer, one, and the function, activation function that we want to use is going to be sigmoid, because it is a binary classification type problem. So the output needs to be like whether the patient has breast cancer or not. So it is a binary classification output, classified output. So that is why we use sigmoid activation function. Then we compile it. Here we do mention the learning rates that we have created from here, and then we mention we take the loss function going to be binary cross entropy, because it is a binary classification type problem. The matrix is going to be accuracy. That is how we mentioned that how do we calculate the performance of the model while compiling, and then we return the model. If we go to the explanation, it says that this allows Keras Tuner to try different number of neurons in the first tens layer, rating from 8 to 28. Here it says that the minimum value is going to be 8 and the maximum value is going to be 128, and the step size is 8. So it will go like 8, and then uh, 8, 18, sorry, 8, 16, and so with the step size of 8 it will keep on increasing and it will manage. So it will try multiple neurons in the input layer, and then the learning rate is going to be, so this will try multiple, this will allow the tuner to try different learning rates, this particular section. And the output is going to be activation function, sigmoid activation function, because it is a binary classification problem. Then we build the tuner. Here we mention the callback for our model, which is this build model. Here we mention the objective is, well, we want to see the accuracy. So let's say what it says. The kt dot random search is going to be, this is how we are setting up the tuner. Here the kt dot random search says that this tuner will randomly sample combination of hyperparameters to find the best. So it will do what? Random search. It will do what? Keras Tuner dot random search will randomly sample combinations of hyper tuners to find the best set. Okay, so it is going to apply with random combinations of parameters to find the model with best performance. Now this second thing, this is the callback function building the model. This will return the model. Now this objective well accuracy, what do we want to achieve with this random search? By configuring different combinations of hyperparameters, we want to have maximum accuracy on our validation data. On our validation data we want to have maximum accuracy. This is what we want to achieve from this random search. That is, the tuner will try to maximize validation accuracy. The validation, the accuracy should be maximum on the model will try to achieve, sorry, the tuner will try to achieve maximum accuracy on the validation data. Now how many different models it is going to try? It is going to try maximum of 5 different models. So tuner will set 5, will test 5 different combinations of hyperparameters. How many combinations we have defined? Maximum would be 5. Execution per trial, each model will be trained 3 times to get an average result. Now each model will be trained how many? The execution per trial is 3. Each model will be trained how many times? 3 times to get an average result which adds stability to that. So it will not rely on the first execution or only on the one execution ran one time. It will be trained, each model will be trained at least 3 times, and the average result is going to be the result or the resultant performance of that combination. Where do we want to store? We want to store it in the my directory, this information, and the project name is the your project name. I want to see if I remove it, will this still work? Now we will apply this search tuner dot search, because this will do what? Here we have configured our tuner. Now we are going to search where we mention the data, the epochs, and then the validation data. Let's do that. So build. So we will do what? Number of units in the first instance. So we want to tune the number of units in the first dense layer. So we will do what? HP units will be HP dot initialize with units. The minimum value is going to be 8. The maximum value is going to be what? 128 maximum value of neurons in the layer, and the step size is going to be 8 HP units. Now model dot add dense. Here the units are going to be HP units that we have defined. The activation function we want for the layers is going to be rectified linear unit. The input shape for the first layer is going to be the x train dot shape, the first as in the not the number of rows but the columns, and here we are going to be, yes, that's it. We have added the first layer. The first layer will be experimented with minimum neurons from 8 to maximum neurons 128 with a step size of 8. Now we will do what? We will tune the learning rate, uh, for the optimizer. We will do what? HP learning. HP learning is going to HP hyper tuning learning rate is going to be a combination of HP dot choice. Here it says learning rate, and the values will be from 0.001, 01, 0.00101, 0.0001. This is, I guess, this is 10 to the power of 2. This is 1 times 10 to the power of 2, which is 1 by 10 raised to the power of 2, which is 0.001. Correct, I was right. See, these are the learning curves. I have mentioned it in the easier terms. Now we are going to add the output layer, which will have one neuron to tell whether the patient has breast cancer or not. Now, which activation function we should use for this binary classification? Sigmoid. Now we will compile the model. Here we need to mention the optimizer as, for that let's add from TensorFlow Keras optimizers import Adam, and we mention it here, Adam, not Adam. The learning rate will be hyper learning rate, that we have created a choice of these things. Hyper tuning choice we have created. Then we need to specify what loss. How to calculate the loss will be binary cross entropy. Then metrics, how to calculate the performance, will be accuracy. Uh, then we will simply return the model. Now we will do what? We will set up the tuner. We have already explored this code, so we will do what? Set up the tuner. So set up there was a typo. Set up the tuner will be, that's one. Set up the tuner will be, tuner will be from kt Keras Tuner dot random search create. Set up the tuner configuration. It is going to be the callback for building the model will come from this callback or build model function, and the objective for this Keras Tuner is we want to have maximum validation accuracy, because a good model is which a model that has better, that performs really good, that has good accuracy on the unseen data. And the maximum trials is going to be, that is how many times that, how many different combinations we want to try. We want to try 5 combinations. uh, then the expectations executions per trial is going to be 3, that is how many combinations while training each model. We should have 3 combinations. And the direct, let me go ahead with directory. I'll say, I'll simply ask, while we on set of tuner, mentioning is required. No, so they are not required. So basically, directory is the folder where Keras. So Keras will store the training logs. That is why we mentioned this directory. Project name helps to organize different projects within the same directory. Okay, so we are not going to. Let's mention it. So here it is going to store the logs, and this will help in segregation of the logs. So directory is going to be uh, day 7, and here will be logs, and here will be, what was the project name? Okay, I have a problem here. Project name is going to be day 7. Problem day 7 will help me better segregate the logs. Now we will do what? We will search for the best hyperparameters. We will execute the tuner. We will search for the best hyperparameters using this tuner. So tuner dot search on this data, which is xtrain, y train. Then we have how many epochs we want to run. We want to run the epochs as 10, and the batch size, we do not mention batch size. Okay, the validation data, the validation data is going to be x validation, y validation. Cool. So we are almost done with our setting up the tuner. Now we will do what? We will go to our get the best model. Now we will get the best model that with the best parameters, hyperparameter. So we will use this tuner dot get best hyperparameters. Here we this retrieves the best set of hyperparameters found during the search. Okay. So this is the best hyperparameters. Then we do what? We build the model according to the best parameters. Okay, so tuner dot hyper dot build, whatever parameters we have received, we are going to build them, and before that we are going to print them. What was the units, what was the learning date that came out of with the best validation accuracy, and then we are going to build the model. Once build the model, we will fit the model on our train the model, and then visualize the model. So let's go what? Find the best hyperparameters and build model. So we will do what? Best, create a variable best hyperparameters. We do that with the tuner get best hyperparameters function. Here we mention the number of trials. We want number of trials as in one try only, and we want to return it. And then we will simply show the best number of units, well, best number of units as in the starting neurons in the first layer is going to be what? Printed with best HPs get in units. Okay, print, then we will print best learning rate. Best learning rate is going to be best hyperparameters get learning rate. Done. Now we are going to build whatever best parameters we have got. We are going to build the model with that. So it is going to best build the best model with those hyperparameters. With that means with that combination yielding the best optimized validation accuracy, using the function on the tuner dot get best model, tuner dot hyper model build best hyperparameters, and then we are going to train. We will train by what? Here we mention build the best model with uh, best hyperparameters. Now we are going to train the model. So we will do what? Train the model and store the history of training in this history variable using the function best model fit. Here we say it is going to fit on x train, and this is the target. The validation data is going to be x validation, y validation, and then epochs are going to be 10. Okay, we want how many epochs? 10 epochs. That's it. Do you want to see it being trained? We do not want, because we assume it is going to have the best result, right? And then we will plot it. Do we want to plot it? Yes, let's plot it. Let's plot what? The graph. So for that, let's do what? Import a library. Import matplot.py, plot as plt, give one more space line, and then we are simply going to visualize the accuracy and loss of best model. So we'll do what? Plot the loss. So build a figure of size 10 is to 7, and then we'll plot the what? History loss of the training data. Okay, so first loss of the training data. Here the label is going to be, okay, so first for that, let's convert it into data frames. So for that, import pandas as pd for converting into data frame. So for that, we will do what? History data frame is going to be panda data frame, and mention this history dot history. Correct. Now here we are going to, it becomes easier to plot the graph with data frames. The label is going to be training loss. This is for training loss, and then we will plot history validation data loss, and the label is going to be validation loss, and the line style is going to be dotted. Line style is going to be dotted. Now we will do what? Have missed one comma. Let's mention the x label is going to be epochs. The y label is going to be loss, and then we will simply show. We don't want to use the legend function because we are clearly saying that the validation will be represented by the dot. So now we will do what? We will plot the accuracy. For accuracy, everything is going to be same. Wherever we have defined loss, just replace it with accuracy. But we did not mention the what title of the plot. The title is training and validation loss, and we will copy and mention the same here. We will say training and validation accuracy. We are done with the coding part. Now let's run the code, execute the code, and then see. So it has trained all the box. See, it is doing that. Let's see that. So this is the best combination. Let me take a screenshot. So this is the best combination. The loss drastically decreases, which is really good, and then it is going steady, and this is also going steady, and the accuracy should increase. It just drastically increase, so that is a good sign. The model should quickly reaches to the best optimum the accuracy. So this is the, and we have mentioned in the tuner that we want to achieve the objective of the tuner is to achieve the optimized validation accuracy. So see, the validation accuracy is optimized here. So let's take this screenshot of this thing also, so that we, even if we miss it, we will be able to get it. We do not have to run the model again. So when we ran the script, we saw that this is how it was producing the output. So for the first trial, in the first trial, it was search the first trial. The value was 64. The learning rate was this. Best so far, 64 was the units that it should start with, and the learning rate was 0.01. Second combination was trial. Okay. Search trial was again, it had found this is to be the best unit and everything. And after the search trial, third time, again the best value so far was this. And then it simply trained the model. So it ran the fourth trial, then also it was the best combination, and then it trained the model. I want to see the other things that it had printed. The validation accuracy in the first, just a second, the validation accuracy in the first trial, it had used uh, okay, okay. It says that it runs slowly, please use this instead. Okay, I'll you do use that instead next time. And then when it was doing all of that, it had found with the different combinations, this was the best. After the first trial, this was the accuracy that it had achieved. Best value for the accuracy was this much. Valuation accuracy C, okay. And total time elapsed was this. Okay. Yeah. So this is the result. I want to see, we did print something like, right? That what was the best number of units. So here if I see the best number of units was 32. Best learning rate was 0.01. Uh, okay, this was after the fifth trial. Before at fourth trial, I want to see. Oh, see, so here I can see different combination it had tried. Here for the fifth trial, it had the combination was 32 and 0.01. And then here we see the combination was 96 0.001. And the combination was here 40 as input and 0.0001. And here the combination was 64 as in first neuron input units, and the learning rate to be 0.0001. So it had tried multiple combination, and the best so far was this one, this one. So this was the best so far. This was the best. So I'll go and mention everything here. So we are almost done with our code. We saw that this was the best. It had tried multiple combination, and this was the best combination. So the model should start with 32 input units, and the learning rate should be 0.01 to yield the best validation accuracy. So yes, and the validation accuracy would be 94%. So I'll go clear it, and let's do what? Commit the code. Git status, git add day 7, git commit -7. Oh, one more thing before I commit. Let's look at the code. Here we can see the code. It has created a directory logs, and there it has created a subdirectory directory underscore 7 that we had mentioned as our project name. Here we can see the logs in this, like trial 1, trial 0, trial 3, everything like that. So it is really cool to look at the logs for better understanding and debugging and everything. So this is how we store the logs also. So I'll now commit. not here. I'll say add code for day 7, and I'll push to main branch, and I'll go to the repository and see, yes, the code is here. So yes, we have successfully completed week 1 of deep learning challenge. In the next week, we will come back and go a little deeper with exploring CNNs and computer vision. So I'm really excited for that. Again, I'll go. I will not go and learn everything on day 1. So we will go small. We will go add the complexity one by one. That is the main intent of this challenge. So thank you very much. Come back tomorrow, and I'll start this week to uh, problems. So thank you.